So I think it's about time we start. Welcome. Thank you all for coming. We truly appreciate it. And before we begin the main presentation, allow me just to briefly introduce the engineering student club that made this whole thing possible. We are a small group of people that makes primary lectures, workshop, excursions, and stuff like that to bring you, the students, something else besides all the learning and stuff like that. We also do social events, which is a thing which I would love to invite you to. The biggest thing that we make in all year is the Tech Fest. It's a musical festival right here in Davidse campus. It will be on the 12th of May, so a lot of great musicians, possibly the best lineup we ever had. Tapped Beer, of course. Other student clubs that will be presenting what they are doing and much more. So I hope we will see you there. If you would like to be part of what we are doing as a student club, we are always looking for new members, so you can scan the QR code to join. Like I said, we are mainly working on presentation like this one on events. It's a really hands-on thing because we are a small team. Excuse me. A small team of people, and you can learn a lot of interesting stuff that you will definitely need in any future profession, because we are not making formulas or airplanes, but we are working with people, developing social skills, making deals with companies to sponsor some of the events that we make. And I think in general, it's a great experience to have. We are also super flexible with your time. It's totally up to you how much you want to spend with us. So we invite you to have a look at what we are doing. And personally, I think it's great, so you should check it out. But if you're not interested, but still would love to see what we are doing, you can follow us on our socials, such as Instagram, where we post the upcoming events and all the stuff that we do, so that you don't miss on anything interesting. And that will be all for me. Thank you, and I will now introduce Dr. Beránek to say a few words. Thank you.
So, hello everyone. I'm pleased that you came in such numbers. Thank you for that. And today it's my great honor to introduce Mr. Andreas Dick, who is the board member of Škoda Auto, responsible for production and logistics. And basically, who else could be speaking about the future of manufacturing, future of automotive industry, than the leaders of the industry. So, Mr. Dick, I would like to welcome you on the stage. Thank you that you came. Thank you very much. And please share your vision about the future of automotive industry with us.
Thank you very much. So, if any questions come up, please put it in the Slido. But of course, I would prefer if you would ask it in person later on, but there's another opportunity. So what do I want to talk today about? First, a short introduction about what is Škoda Auto about. I think most of you, of course, know Škoda, but I think it might be interesting to learn a little bit more about what's really in detail behind. I would like to talk a little bit what's going on in the world nowadays. What does this mean for the automotive industry? And what does this mean then specifically for our production area and, of course, then for you as engineers in the future? So, beginning with a little bit with the history of Škoda, because, most of you are Czech probably, I think you know. Škoda has a very long history. Last year we celebrated 100 years of the company, starting as a bicycle company, which, as a fun fact, was founded because the two guys on the left bought a bicycle from a German bicycle company, and they were so disappointed about the quality that they decided to build their own bicycles. So very shortly after, started to produce cars. then very successful, especially before the Second World War. Then the unification with Volkswagen in 1991. Like I said, last year we celebrated then 130 years of the existence. And in fact, we are really very successful at the moment, producing more than 1 million cars. Last year, number 3 in Europe by sales volume. In the first 3 months of this year, already number 2. We surpassed Toyota. This will unfortunately not last because they have quite a problem in their model cycle at the moment. But I think position 3 is already a great achievement. Footprint in Czech Republic. You can see here we produced nearly 1 million cars in Czech Republic alone. 3 locations: our main plant in Mladá Boleslav, a plant in Vachlaby where we do gearboxes, and a big plant in Kvasiny for cars. And it's not only about cars. We also do quite a lot of components, engine, gearboxes. I will tell you this a little bit later. But it's not only about Czech Republic. We have quite a big international footprint. We are doing, of course, like I said, most of our cars here in Czech Republic, but also in the factory in Bratislava. We are, as Škoda, within the Volkswagen Group, responsible for Southeast Asia. So we have 2 factories in India, which is at the moment the biggest single growing car market in the world. We just opened a factory in Vietnam, and we have a facility in Kazakhstan. And shortly coming will also be the production of the Škoda Epic. You can see it just outside in Pamplona in Spain. With a quite big product range. You can see here the cars with a traditional combustion engine, small ones, big ones, but more and more important also now the electric cars. At the moment only the Elroq and the Epic, the Elroq and the Enyaq, but the Elroq in the meantime the most selling electric cars in Europe in a lot of months, most selling electric car also in Germany. And surpassing also, I think, in the first 3 months this year, the Model Y. So quite a big success. And now with the Epic and the Peak, we extend the model range at the lower end and the upper end, and you could see these 2 cars outside. So we are really very much committed also into electric cars. And on the lower part of the chart, you can see the cars we are doing mainly for India and Vietnam, which are specifically designed for these markets. But like I said, not only cars, we are also doing quite a lot of components, producing more than 500,000 engines a year. And also for the electric worlds, we are now at Škoda within the Volkswagen Group, the biggest producer of battery systems. Yeah, so we are doing several thousand battery systems also a day. And on the right side, what is also now a very interesting topic, with new model generations, we will also now go into gigacasting in the future. Something, which Tesla started at the beginning, but which is also now implemented by a lot of Chinese companies. And also, fun fact, a lot of people don't know, the aluminium die casting, which is the technical foundation of gigacasting, was invented also in Czech Republic in the 1960s. In Mladá Boleslav, which is Skoda 1100. Yeah, so it started also here. So coming now a little bit to what's going on in the world. I think this is something, we really have a changing world order, and this is affecting the whole industry. Yeah, we see a geopolitical shift, and this is leading really to also a technological disruption, a lot of challenges in the supply chain, which is heavily affecting a lot of industries, but mainly the industries that are very international, with a very international footprint, with very international supply chains. And to just mention a few, can see here, we have a situation in Europe where we have emission legislations which are, I'd say very challenging and very volatile. Yeah, so it's completely difficult to make a planning for an environment. If you are in the car industry, you are planning a model cycle normally 4 or 5 years ahead with everything that belongs to this. You have to plan what kind of drivetrains, what kind of specification. And if you then have a situation where the legislation is permanently changing and in a limbo, this is very difficult to handle. We have a situation in the United States which is unpredictable. Yeah, I think you all know from the news. We have a situation with the invasion of the Ukraine 4 years ago, which also affected us very heavily because we also had been as Škoda responsible for Russia. So we had to close down our operation in Russia completely. We have a situation in China which is very challenging, where you have a very dynamic environment. I myself worked for more than 13 years in China during my career, and I could experience what's going on there. They are very fast. There are a lot of competitors. You have more or less 200, more than 200 electric car companies in China. Yeah, most of them you have never heard about, but they created huge overcapacities, and now they try to export their overcapacities, and that's what we are also facing it a little bit in Europe, but much more in other parts of the world. And last but not least, we have the situation in the Iran war, where we don't know how long it will last, which have a huge impact of the supply chain. So this is all the things you have to handle. And this is leading to a situation that the markets are really changing. Yeah. If you look at the past, where we are operating in as a car industry, you had over 60, 70 years a pretty stable environment with classical OEMs with a more or less simple portfolio. But this is now, like I already mentioned, changing dramatically. Yeah, we are coming now in a situation where we have on the one hand to operate in the old world, let's say with ICE cars. And on the other hand, we have to bring now all these other drivetrain options into the market. This means in a lot of cases, you have to double up your portfolio. Yeah, I showed you our portfolio. We have now an ICE portfolio. We have a BEV portfolio. And it's very difficult to predict in which direction development will go in the next few years. We have, like I already mentioned, a legislation in the European Union, which first was very strict regarding end of combustion engine 2033. Now this is again in discussion. Yeah, we don't know where this will lead, and of course we have the global politics, where we also don't really know what will happen in the future. And just to give you a glimpse about what does this mean in Europe, and we as a company are operating to 80% at the moment in the European market. What you see here is the challenge we are facing with this electric transition. The chart looks more complicated as it is to understand. We see in the yellow curve what was the initial target within the European Union to come to 0% ICE cars in 2035. Yeah, with the underlying CO2 targets. What you see in the red curve is the transformation curve in Norway. Norway, I think you know, is at the moment already a market where you have 100% BEV cars. But what happened in Norway is that they put a lot of money in it. Yeah. Interestingly, they pay this with the money they get from the export of oil and gas, but okay, they put a lot of money in it. And also in Norway, they had very early a lot of tax benefits for electric cars, and they had a very good charging infrastructure. This is a situation we don't have in the European Union yet. There is no big subsidy programs regarding electric cars, and there is, in a lot of countries, no charging infrastructure yet to support such a transformation curve. And this leads now to a situation that we have a legislation in the European Union that still requires this, but we have no framework within a lot of countries that allows it to do it, and no financial support to do it. And this is really leading, forcing the car industry in a big dilemma. And it's also a situation when you look also, coming to the Chinese a little bit later, when you look with the Chinese have a very fast growing car market share within Europe. They are at the moment already at 7-8%. Yeah, not here, not in Germany, but especially in Southern Europe, especially in the UK with MG, which is not an English brand. It's in fact a sub-brand of SAIC Motors, which is a Shanghainese car company. And in the press, you would think all the Chinese cars are electric, but this is not the case. There are only about 30-35% pure electric. There are another 30% PHEVs, so plug-in hybrids, and there are around 40% combustion engines. Yeah, so you see they are also on a different path. So what does this mean now, and why is this leading to a situation that automotive is changing? And now it becomes really relevant for you as future engineers. If you look at what was a car yesterday, traditional car. A traditional car was mechanically defined. Yeah, it's all about engineering, mechanical engineering. It's hardware-centric. And if the car is built, it is like it is until you scrap it. Yeah, there is no big change in the car. And it's all about, like I said, all about hardware, about reliability, about driving experience. Yeah. What we see today is completely different. And we don't see it that much here yet, but we see it in markets like China and also in markets like India, that the cars are more and more software defined and connected. Yeah. You have more and more the situation that you buy a car with a specific functionality, but over lifetime with a specific electronic architecture in the cars, you can add specific functions. It's more and more like a mobile phone on wheels. And this is leading to a situation that the cars have a much lower differentiation through the hardware. Of course, driving performance is still an issue, but the software becomes more and more relevant, and it becomes more and more relevant how the cars are able to be updated after the production, after you buy it, because you want to have people will get used to have more and more functions and optimizations they get via software, like you have it today on a mobile phone. The other big thing is autonomous driving. Autonomous driving will become more and more normal in the future. Yeah, I was last week in China, and on Chinese roads, you already have the situation that you can drive in a lot of areas more or less fully automatic. Yeah, you have other legislation. Yeah, it's and also the cities itself where you can do it are much more connected. But I made experience. They picked me up from the railway station. We drove to a factory for half an hour, just programming the navigation, and the car was driving alone. Yeah. You have to touch the window, the steering wheel from time to time. The camera's observing that you are not doing something else, but it's driving alone, and it's changing the lane on the highway. It's going over very busy crossings. So the technology is there. What's still missing, especially in Europe, is the legislation, the framework to make this also happen here on European roads. But it's not a question of technology. Yeah, it's just a question of legislation. Another thing, where this is now leading to, is that also then production is changing. Yeah, in the past, production was focused on combustion vehicles, really on hardware, not the car only itself, but also the engines, the gearboxes, the axles, and so on. But this is now really completely shifting in other areas. We are having now to produce in parallel also electric vehicles, PHEV, hybrid vehicles, with a complete change in the electronic architecture of the cars. So in the past, you have a very decentral architecture of the electronic, will mean developed without the traditional car concepts. You have a lot of steering devices distributed all over the car. In the new electronic architectures, you have one or two central computing units, and they are steering all the other devices in the car, which then allows you to do, for example, over-the-air updates. But this is also leading to a completely different setup in the production, because for the production you have now the advantage that you have somehow an intelligent product, yeah, from a very early stage. You start to produce the car, but very shortly after the car gets its computing units, you can really use it as a device with which you can operate. So the car can also check itself if all the functions are okay, if the connections are okay, if all the functions are there. And it also functions like autonomous driving allows you then also to do driving checks within the car, within the factory itself, by the car itself. Yeah. So we will see more and more autonomous processes in the production area. And this also leads now to a situation that we, of course, then also need a completely different process and production technologies. So in traditional production lines, you see coming from Ford, Model T, very fixed lines where you have this sequence production. This is completely the past, because in these fixed lines, you have a very rigid system. So whenever you want to change something, it becomes very, very complicated, and you have to invest a lot of money. And you have long configuration cycles when you want to bring a new product in. And of course, it has very low flexibility. In new factories, in the factories of the future, you have very modular layouts. That means you can steer the production for every car more or less independently, depending on the needs. You have a lot of virtual processes where you do the planning virtually before it really comes into life. We are working already a lot with digital twins. That means we are simulating the factory, and before we do something in the hardware, it is completely simulated and planned within the digital twin. And this means that everything we do is now, I call it, born in simulation. That you can really plan everything, simulate everything before you then really go into the hardware, which gives you much more flexibility, much lower implementation time, and of course, much lower cost. And to just give you a short example how such a digital twin look like is shown here. This is a digital twin of a press shop. And the digital twin is, like you can see here, it's not only the installations inside a press shop, for example, it also shows you all the whole environment about climatization, heating, cooling. If the doors are open and closed, you can control the whole system within a digital twin. And this allows you to react much faster if there is something not okay. Even if there is, for example, a rolling door is not working in winter, you get immediately a signal that gives the maintenance the information that you have to go there and check, because heat from the inside is flowing out. Another very interesting thing at the where we are facing is the topic of robotics. I think you all saw probably the videos about the humanoids. It's now really a fancy thing, but this is really a very dynamically developing field. But we are far from seeing humanoids working in factories. Yeah. What I brought you here is these are the different levels of automatization. What we have nowadays is mainly level 1 and level 2. Yeah, level 1 is what you see. This robots in fixed lines do spot welding, are programmed. This is something we have fully implemented. Visual perception in robotics is the next step, which is also already far developed. This is the step where you don't have a fixed programming of the robots, but you have robots that have the possibility to get a visual impression of their surrounding and do, for example, bin picking. So pick something out of the box because they can detect with the cameras where the parts exactly are. This is also, which is already very much implemented in the factories. When it now, I was too fast. When it comes now to the next level, there it becomes tricky because this is now where robots have to be more and more the ability to act like humans. This is called dexterous manipulation. This means that the robots are able, for example, to handle something like this, like a cable, which is not rigid. Yeah. So if you grab as a robot this cable and you would to put it somewhere in a connector, you really have to have a good feeling to then bring it together with something that is not very stable. This is something we are working intensively on because this is something that becomes very relevant in assembly processes. But this is work in progress. And I think we will need probably 2 or 3 more years to really handle this in an industrial scope. The next thing is then level 4. This is conditional autonomy, and this is where we are now coming in an area where we would see then autonomous robots working in an industrial environment. But it's still something where you give them a very clear, defined task, where it's not necessary to understand the whole surrounding. An example is, for example, if you have a robot that put everything out of your dishwasher. This is something, a clear, defined task, which is not very complicated, what you don't need to train that much, but it's a complex task because every time the dishwasher could be sorted differently. And at the end, level 5, full autonomy, this is where you see all the simulations at the moment in the internet where they simulate level 5, but it's not. Yeah, because this is really the level where you then need to have robots that really are able to detect the environment, to know exactly what to do when, and also have some kind of intelligence. But this is still far away from the realization. But what this means today in the factory, for example, in the implementation of robots, this is shown here. It's already a high level of robotics, but this is like industry nowadays look like. This is how we are producing the battery systems. Highly automated, very few people, with robots that are already able to see their environment, to adapt on a little bit on their environment, but not really in a way that I would call intelligent. Same for the logistics automatization, where we use a lot of these AGVs, which are operating more and more independently in logistic routes in the factories, but still not with an intelligence on their own. And this is also when you look in the direction of humanoids. These are the ways we need the robots to look like in a factory, not because the human physiology is not really ideal for an industrial scope. Yeah, you don't need legs. Yeah, so probably it will be more robots you will see more and more robots in the factory, but they're really probably looking more and more look more like boxes with very specific arms. And this is where we are working on at the moment, that we go from a rigid automatization to more and more adaptive systems. Yeah, really then use artificial intelligence to make the robots that are operating in an industrial environment more and more independent and are able to performing tasks that originally be designed by humans, but where you don't need, let's say, too much intelligence to do it. Yeah, so more and more the boring stuff, and we need to be able to do this in our existing brownfield environments, because we have traditional industrial structures, and we need to adapt these technologies in these existing structures. This is now more and more leading to a situation that we really can bring more and more robotics in the factories, because it is more and more feasible. But like I said, we should not expect to see something that is shown here in the next video, which I think probably know. This was from China. They do one time a year at Chinese New Year a huge show, and this time they made a show with robots. Looks impressive, but it looks like the robots will really act like humans, but in fact they don't. Yeah, they're really trained for weeks and months to do a performance like this. But nevertheless, coming now to another step is that AI applications are becoming more and more now as an operating system of the production. Yeah, it's no longer a tool. Yeah, it's not something to play games, to create videos. AI in production in the factories become more and more part of the infrastructure. What does this mean? We are already in a situation that we use AI to do predictive quality and maintenance. So what does this mean? We have replaced a lot of visual controls in the meantime with optic systems that are trained by neural networks, that are trained by large language models, where we really replace people standing there checking the quality with camera systems which are doing the same and which are in the meantime very cheap, and it's very easy to train them, or very fast to train them in the meantime. Yeah, we do AI-based planning and scheduling, for example, in logistics, where we are optimizing logistic processes, the loading of the trucks, for example, with AI tools to really bring them in the right order to the right suppliers to have an optimal logistics process. Yeah? We use AI for support of maintenance, so that machines detect themselves if there might be a problem, and the machine themselves is calling then the maintenance people to tell them, listen, I detected something that might be wrong. This already happens. Yeah, and of course, to do then all the surrounding support systems. And to give you an example about what does this mean for the camera systems, here is an example for something we call the Vision Kit. This is a device to democratize computer vision. Yeah, this is something, a toolbox where people really can bring them in the production if they find something where they would like to optimize, where they think there is a use case, and there is everything in to set up the camera systems with the computer, to train the camera systems, and then to make a proof of concept. In the past, this kind of things with huge camera systems had been very, very expensive, took a long time to install. Now we have, in the meantime, in the factories, in all our factories, I would say hundreds of use cases to really do optical control trained by AI to really then improve our quality situation, to do the detection of abnormalities in the factories, and so on. Another example of the use of AI is what we call our production co-pilot. This is a tool that is using a lot of different data. It's with more a data lake where you have all the information coming out of the HR systems, quality systems, sales systems, put them all together in an analytic platform. And we are more and more then using AI models to get the relevant data out of this data lake and create then relevant information or necessary information for the production. So one outcome I just described, for example, is for the maintenance. They can get the relevant information they need about the quality or quality problems or breakdowns or potential breakdowns out of this data lake, and then take action regarding this. Or if you need to make planning for a specific device, you can write a prompt and give the AI agent the question, the task, what to do. And this is really developed incredibly fast with the possibilities we have. We have a lot of cooperations also here with Google, with their AI agents. And this is something we are seeing more and more in the factories. What does this mean now for you as engineers for the future? It means that you need different skills than in the past. Yeah, we just discussed this a little bit before we came in. In the future, or already nowadays, there is no separation between mechanical engineer, electrical engineer, and informatics. You need a mix to work in this environment. Yeah, you need really a general understanding of AI and automatization, and the most important thing is really be able to think in the whole system, because everything is more and more connected, because we are more and more in a less stable environment. Yeah, the future is not as predictable as it was 5 or 10 years ago. Yeah, we have permanent changing frameworks, and we have to adapt. And this lead to a situation that it's no longer that important really to locally optimize, to really reach 100% perfection. It's more and more necessary to have an end-to-end thinking, and to think more in solutions, and with a high probability of an outcome. It's a little bit difficult to explain, but maybe with an example from autonomous driving. If you have an autonomous driving car, these autonomous systems are working not based on 100%. They have their cameras and they check the surrounding, and if they have a probability of 70 to 75%, the system say it's 100%, because it then has a probability of really 99.99999. Yeah. Same when you have quality control with these optical systems. If the camera look at something and say the probability that this is now okay is 70%, it's normally nearly 100. And this is a change in engineering thinking, because you cannot wait until you have 100% security because in an implementation, because this takes too long. Yeah, you have really to think different in when it is sufficient. But what does this mean? This is now really a great chance to influence the technology, to really shape how technology impacts the society. Because we see so fast changes in our industry that it's now a really fascinating time, because we see now within 1 year or 2 years changes that have not been in the last 70, 80 years of the car industry. This has never been before in this speed. And the car industry is really, in a lot of areas now, defining this kind of development. And so I think you are really in a lucky situation that you are now studying in this area, because it gives you a real good opportunity to be part of this really fascinating development in the future. Last but not least, as I promised to my colleagues, I have to make a little bit of promotion. I just gave you a little bit of glimpse of what we are doing at Škoda. We are always looking for talents. Yeah, I hope I could give you a little bit of an impression how fascinating it is, what's really going on. So I can only recommend to get in contact and try to be part of our future. Thank you very much, and I am now open for your questions.